All right, welcome to the Explainer. Today, we're going to dive into a concept that's, well, it's so fundamental it's hiding in plain sight. It connects everything from life itself to the memes on your phone. We're talking about transmission, the invisible engine that keeps our world, and everything in it, moving.
So, let's start with something really simple. Think about a secret. How does it survive? For it to keep existing, it has to be passed on, right? From one person to another. It needs a channel. It has to move.
Okay, now let's scale that up a lot. What about an entire species? How does it manage to survive across thousands, even millions of years? It's the exact same problem, just on a massive biological scale. Something has to be passed on.
And why stop there? Let's go even bigger. Think about a whole civilization, its laws, its stories, its culture, all of it. How does any of that last longer than a single generation? How does it actually persist through time?
Well, the answer to all of these questions is transmission. This is the big idea for today. It is the engine of continuity. It's the fundamental process that allows anything, whether it's an idea, a life form, or a society, to hang on and move through a world that is constantly trying to tear it apart. So, where do we even begin with something this big? Well, let's start with the original, the most high-fidelity transmission system we know of, life itself.
Genetic transmission is, for all intents and purposes, the ultimate blueprint. Our source material calls it the molecular syntax of life, which is just a beautiful way of saying it's the language, the grammar, that literally spells out how to build an organism. DNA is basically a biological algorithm, and it's passed down with incredible accuracy, generation after generation. I mean, it's the physics of inheritance.
And here's what's so cool about it. The message being sent, that's the genetic code. Now, the fidelity, the accuracy of the copy, has to be insanely high for a species to stay stable. But the tiny little errors, the mutations, that's where all the variation and adaptation comes from. So you have this incredible balancing act between perfect copies and slight changes, and that is the engine of evolution right there.
Okay, but for anything to be transmitted, it's got to have a place to live, right? And that place is called the host. Now, a host isn't just a passive carrier, not at all. It's both a medium and a multiplier. So a body can host a virus, which lets it replicate and spread. And in the exact same way, a mind can host an idea, letting it replicate and spread too. So, that's the perfect jumping-off point to see how this whole process moves from biology into culture. Because the same rules of replication and evolution that apply to our genes, they apply to the ideas that live inside our minds.
Before we had writing, humanity's #1 way of passing on culture was just the spoken word. You got to think about things like epic poems or ancient myths. These weren't just stories. They were systems with built-in error correction. Things like rhythm, rhyme, repetition. They were all clever hacks to make sure the stories survived the trip from one mind to the next, fighting against the natural decay of human memory.
And what's the modern version of that? Yep, the meme. The source material actually calls memes cognitive viruses, and it's a perfect description, right? They're ideas that infect our minds, they replicate, and they spread from person to person. They're all competing for our attention, and only the fittest, the catchiest, the funniest, the most powerful ones survive. It's literally cultural evolution happening at the speed of light.
Which, of course, brings us to today, where we've taken these natural principles of transmission and we have engineered them into something ridiculously powerful.
Because, at its core, every single time we try to communicate, especially in the digital world, it's a battle. It's this fundamental conflict between order and chaos, between the message you're trying to send and all the forces out there trying to scramble it.
And this slide really lays out that battle perfectly. On one side, you've got the signal. That's the pure, structured information you actually want to send. But on its journey, it always runs into noise. Static, data loss, a misunderstanding, just all the random stuff that gets in the way and corrupts the message. And the central challenge of all communication tech is just trying to preserve that signal against a world full of noise.
So to win this fight, we're forced to make a choice, a really strategic one. We can go for a lossless copy, which is a perfect bit-for-bit replication. Think of a zip file, nothing is lost. Or we can choose a lossy copy, like an MP3 or a JPEG. It sacrifices a tiny bit of perfect fidelity, but in exchange you get these massive gains in efficiency. You're trading perfect precision for just incredible speed and size. It's a good enough copy.
Okay, so how does any of this actually work on a global scale? How do all our devices talk to each other?
The answer is protocols. Things like HTTP for the web or TCP/IP for the internet. These are the shared rulebooks, the universal grammar that lets different systems communicate. The source material calls them the DNA of coordination. And that's just brilliant, because just like DNA provides the code for life, protocols provide the code for our digital world to actually work together.
All right, so we've talked about genes, we've talked about ideas, and we've talked about data packets. Now it's time to zoom all the way out and see the grand unifying pattern that connects every single one of them.
And wow, this chart here, it just ties everything together so perfectly. Take a look. At the biological level, the mechanism is replication, and the goal is the continuity of life. Simple enough. Move up to the cultural level, and the mechanism becomes communication and imitation, all for the continuity of meaning. And finally, at the technological level, it's encoding and protocols, all to achieve efficiency and scale. It is the exact same pattern, just playing out in different arenas.
So here it is, the big takeaway. Whether we are talking about a strand of DNA, an ancient story passed around a fire, or a stream of data packets flying across the internet, the core process is identical. It's all about achieving continuity through change. Transmission is what allows a system to keep its identity by making copies while also allowing it to adapt and evolve through tiny variations.
There's this fantastic quote from the anthropologist Gregory Bateson that just nails it. He said, "All systems survive by transmitting their difference." Think about that. A system doesn't just survive by making a perfect copy of itself. It survives by successfully passing on the unique information that makes it different from everything else, fighting its way through all the noise of the universe.
And this all leads to a pretty profound conclusion. The very nature of existence seems to be tied to this process. For anything to persist, for it to even be, something has to be in motion. Something must be passed on. Transmission, you could say, is the pulse of information itself.
So, if we really take this idea to heart, that to exist is to transmit, it leaves all of us with a really powerful and kind of personal question. In your life, in your work, in the things you care about, what are you passing on? That's our explainer for today. Thanks for joining us.